Hello everyone. Now we are going to move toward the next assignment from our data structures and algorithms laboratory, and the next assignment is from group E, which is based on the Heap data structure. So according to the syllabus, we have to cover one assignment from E group as per the syllabus. Here it is shown, and the names given in the assignment, different three assignments are given over here for the implementation of some of the records or some data according to one of the data structure we have to use. So here we are making the use of Heap data structure. So this assignment, that is assignment number 22, we are going to perform, where we have to read the marks obtained by students of second year in an online examination for particular subject, and then we have to find out the max and mean marks obtained in that subject. So we have to use the data structures, that is Heap data structure we have to use over here. So let's start with this assignment. So here we are having the assignment, but as usual I am having a version where I have marked some comments over here so that we can easily understand the concept. So here we'll start with the explanation of this assignment, where we have to read the marks which are obtained by students of any particular year and in particular subject. So we have to find out the maximum as well as the minimum marks that will be obtained in that subject. For that we have to make a use of Heap data structure over here. Now here some header files we have included as per our requirement, and the next we have defined one class. Now this data we have to create for the student. So we have created one class for the student where we are taking one array which contains the marks of that different student. So here we are taking the marks of only one subject. So as per that subject marks, we have to store the data of number of students in that array, and from that array we have to find out the max and mean. So we can create the max, heap, mean, heap according, and we can work out over there. So here we have created one constructor, that is student constructor, which is initializing the array over here. So array from I is equal to 0 up to the size of max. So max is nothing but whatever the array size we have defined, that will contain the max. So up to that we have to insert 0 0. So this is what initialization of the array, which is in which we have inserted 0 0 in each field. Then next come, we have declared some functions over here, like for inserting the element into heap, then displaying that heap. We have to show the max, we have to show the minimum marks, maximum marks. So for that we have written, we have declared some functions in the class student, and now we are writing the definition of function outside of the class. And while we are doing such a thing, then we have to make a use of scope resolution operator. So here we can see, whenever we are writing the definition, we can see that here the scope resolution operator is used. Now before going towards this definition of this functions, first we'll see main function, where that call exactly, the functions get called exactly. So we'll see that main function first, and then we'll move towards the definition of each and every function. So here it is our main function, where we have declared here is the main function where we have declared some variables as per the requirement, like ch, then we have the total variable, temp variable, count variable likewise. Now here we have again created one object of our class. So class is student, so we have created object s1 of the student class, so that we can access the member functions of that class. Now we have displayed the menu to the user, that which operation we are going to perform on that heap. So the first is we have to read the marks of the student, that the marks of the student should be taken from the user. Then we have to display that mean heap. So we are going to display this heap by using the mean heap. We can also display it by using the max heap if we require. So here we are displaying the mean heap. Mean heap means where the root element is always less than its child element, that is we are calling it as a mean heap. And what is the max heap? Whenever the root element is always greater than its child element, then we are calling it as a max heap. So here we are implementing mean heap. Then next come is we have to whatever the marks are entered, from that we have to find out the max and min marks. So these are the choices 3 and 4, and we have to take the choice from the user in the variable ch, and that will be passed to the switch case as a parameter, and according to that value, that selection we have to execute, we have to call the function accordingly. So here if it is a case 1, that is a choice is given as a 1, then we have to ask for the number of students, for how many number of students they want to insert the marks. So that will be taken in total, and that will be passed as a parameter to insert heap, so that much marks, that much will be that much students marks will be get inserted in the heap. So if our total is 10, so that total 10 is get passed to that insert heap, and insert heap then take the 10 number of times the marks will be taken from the user. So that is why the student count is get passed as a parameter to that insert heap. Now case 2, if the choice is 2, then we have to display the heap. So here we have to display the heap according to the min heap, because we have given the choice as a display min heap, so it will display the min heap. So for that we are calling the display heap, where we are using the object of the class students to call that function. Then next come is third choice, that is the show max. So we have to show the maximum element from this heap, then minimum element is nothing but marks here. So max and min marks we have to show by using case number 3 and 4, and again we have to ask for the choice. If they want to continue with the same given choice, then they have to press 1. So in this way we have seen the main function, which after the end it is returning 0, that is nothing but it is the integer main, and that's why it is returning 0. Now we have to see the definition of that function. So let's see the definition for each and every function. So here it is the insert heap, right? So from insert heap we have to learn. So in insert heap we have to see here it is insert heap. Now we have to see this insert heap function over here. So what that function is giving us, the function that is going to be insert the data in that heap. So here insert heap will take the marks first, because initially in main function we have just asked for the number of students, and that count we have passed over here as a total, right? Now that number of students will be taken in the variable total, and now we have to use the for loop up to that total. For loop will start from 1 and up to the total count of students we are creating one array, and that in that array we have to put the marks of the student. So we'll ask the student, will ask the user to please enter the marks, and the marks will get entered over here. Now here we can see that the for loop we have created from I is equal to 1 to total. So now suppose total is equal to 10, so 10 times it will ask to enter the marks, because we are taking for a particular subject only. So it will ask for every student the number of marks we have to enter. So here we are entering that total number of marks up to the total times, and then we have to insert that. But after inserting a single term, what we have to do, whenever we are inserting that into the array, it should be inserted according to the min heap. So for min heap we have to always make the comparison. Now suppose the first field is filled. Now for the second field, if we are putting the marks over there, then we have to compare that marks with the previous elements. If it is minimum, then it should be at the first point, because in min heap the minimum marks will be the root element, and according to that we have to maintain the heap structure over here. So for understanding of this assignment, at least you should know the heap data structure, that what is the min heap, what is the max heap, and one more important thing, that how we are representing the heap by using array. That much knowledge is required to understand this assignment, because we are ultimately working on the array, which is nothing but the representation of the heap data structure. So here we are working on the min heap. So you should know that much concept here to understand this assignment. So I am assuming that you all know this concept, and moving forward. Now when we have to insert a entry at the first I is equal to 1, because our I pointer is starting from 1. So we have to insert the first marks entered over here. But with that we have to also check if there any other previous marks are entered, and now this new marks is less than the previous one, that we have to check. So how we are going to check? So this give this new index to I also, that is j. So now here j and I is same, so I is 1, so j is also 1. So I am calling this I is also as a j. Now j is also starting from 1, and with this j now I am finding one partition over here, or one indexing over here, that is a partition index, where we are finding j by 2. So as our j is 1, 1 by 2 will be 0.5. So as we are mentioning it as an integer, so it will take 0. So at 0 index, is there any available? No, our indexing is starting from 1. So at 0 there is nothing available. So we have to go towards the next one. So while marks of j is less than marks of that new partition, and j is not equal to 0, but here our value of j is 0. So as one of the condition get fails, so no need to check this second condition, and the while loop will not be get executed over here. So after completion of this for loop, again we have to insert the next element. Now suppose the first element we have inserted 50. Now the next element we have inserted 45. Now what is the next thing we have to do? Same way, after making that I is incremented, so I is now 2. At the marks array of position 2, we have inserted the marks 45. Now what is my I now? 2. So what will be the j? J is also equal to I. So j is again going to be 2. And then we have to find out this partition, that will be 2 by 2. That is j divided by 2. So 2 by 2 it will become 1. The integer value we have to take. So it is having answer as a 1. Now we have to check, that is j is equal to 0. So is it j is equal to 0? No. So we have to check now this condition, marks of j. So marks of, what is the j? 2. So whatever the marks at 2, whether they are less than the marks of partition. Partition is what? 1. So whether they are less than 1, so here marks of 2 are 45, marks of 1 is 50. So whether 45 is less than 50? Yes, it is less than. So if this while condition is true, then what is the next thing we have to do? So here we are having our next thing. So here we have to do the next part. So what is the next part says? If such a condition occurs that your 45 is less than 50, then your 45 should come here and 50 goes here. So for that we have to use the swapping technique. So here we are doing the swapping. We have created one temporary variable where we are copying the marks of j, means the 45 will get copied in the temp. Here we can see. Then in the marks of j, means at this 2 position we have to shift this 50, that is the marks of 1, and then at the marks of 1 we have to insert the 10. So the 45 and 50 get shipped now, and again we have to calculate the j. So why we are again calculating now? Again for this 45, if there any previous elements are present, so again we have to compare that 45 with the previous one also, and again for that we have to update this j. Now my j is this one, that is nothing but our partition, and then again we are going to find out the new partition, that is j by 2. So again we will check for the previous element, and likewise until rj becomes 0. So this condition is get unsatisfied when your j is going to be 0. So we have to do this j by 2 until our j is going to be 0, and once our j is 0, then we have to exit from this loop and again accept the next marks if there will be any requirement. So according to this, this insertion will be done in the heap. Now next come is how to display this heap. So here we are going to display that heap in the form of tree. So when we are displaying the tree, so some space will be required to show the elements. So we can see here the 45, 50, then 60, then again 50 is having like 70, 80. Here we are filling the elements level by level, not like a binary search, the lesser element on the left side, greater element on the right side. This thing is not in the heap. Here we are just filling the elements level by level, but only the thing we have to keep in mind that if we are talking about mean heap, then root should be always less than the children's, and if such a thing is not there, then we have to do the reheapification, either the reheapification upward and downward, but we have to reheapify this function if there is a need. Now what is the next thing we have to do? This reheapification, or that consideration of smaller and greater element, we have done in this array construction itself. So here the array is now, whatever the array will get from this, that will be a totally sorted array. So after that, what is the thing we have to do now? After this, we have to display that heap. So that heap we have to display. For that, we need to be display this spacing also. So for that spacing, we have taken one variable space which will have the value initially 6. Now whatever the total number of count we are having, that is the number of marks, up to that we have to execute this for loop, and for 1, 2, 4, 8, 16 up to this, what we have to do? We have to insert the space. So how we are inserting this space now? This space is for this. Because as we are talking that heap is a complete binary tree, or we can say near about complete binary tree. Heap is near to complete binary tree, means it is filled level by level. So at the first level the node will be 1, at the second level node will be 2, 3, next 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, then again it will start from 16. So for I is equal to 1, for I is equal to 2, for I is equal to 4, for I is equal to 6, for I is equal to 16, always we have to take the next line for a printing. So here we have to take a next line. So here we can see that for I is equal to 1, 2, 4, 8, 16, we are going towards the next line. So here we are ending that line and we are moving toward down, and then we are inserting that element one by one, like this element, then space will be allocated over here, then again the next element, space will be allocated, and likewise we are printing that elements from the array. So here the first element will get printed, then this cout function will be executed, because now our I is equal to 1, so we have to move down. After moving down, we have to print this for 2 and 3, we have to print that 2 next node. Again after 3 there will be count incremented, I will be plus plus, I plus plus, here it is written, so I will becomes 4. So 4 means again this condition, so again we have to move down. So from 4 we have to start to filling this level, after 8 we have to start filling this level, after 16 we have to go again one level down. So likewise we have to perform this one by one, and in this way the spaces get inserted between the nodes, and now it will look like this structure. So in this way we have to display the heap. Then next come is how to show the maximum element. As we have displayed the mean heap, so maximum element we have to search in this heap. So for that what we are going to do? So very first element we are assuming as a maximum element, and we have taken that in the max variable. Max1 variable contains a first element of your array. Then from the second element onwards, we have to compare that first element that we have taken as a max element. That element will compare with the every next element from indexing 2 and onwards. So for every next element we have to compare that, and if we found that our max variable is less than the next element, then we have to update our max, because the next element is larger than this max variable. So now the max one will contain that current element over here. So in this way, if we have finished our search, the whole array is get finished. Now then we have to print whatever the max one is updated, that we have to print over here. So we'll print likewise the max element. And what about the mean? It's very easy. Root of that heap is nothing but the mean element. So according to the heap, we have to store the first element in the first position. Root element will be the first position. So whatever the first element will be in the array, that will be surely our minimum marks, because that array is going to be in sorted form. So that's why we are having our first element as a minimum element, so we can directly show that. So as we are using the mean heap concept, so mean element will be the top, or we can say root, or the first element from the array which we are displaying over here. So with this, all the concept and the functions are explained over here. Now we'll see how this program is going to be executed. So let's see the execution of this. So here it is, we are having our program. So we just copy this program. Yeah, so here the program is get copied, and now I am going to compile it on the online compiler. You can use any of the online compiler over here to execute this. So here I will paste that, and just I must say I have to run this. So here I am running this, and now you can see the program is get compiled. So here we have to give our choice. Now suppose my choice is 1, because I have to put the marks for the student. Now how many students are there? For example, there will be the 7 students suppose. Now I have to enter the marks, so we are going to enter the marks like 60. So it will ask 7 times. You have to enter the marks 7 times, because for all students for one subject we have to enter the marks. Then after 60 there will be now suppose 85, then it comes 20, we can say it becomes the 32, then there will become 45, then next is the 66, then next will be the 47 suppose, and next is 80. So I think the 7 are finished. Yeah, so 7 entries are there, and now if you want to continue, then we have to press 1. So I say 1, yes, I want to continue, and I want to display the mean heap. So now your heap, you can see that minimum marks is there. So this, from this, which is the minimum, 32 is minimum. So 32 is now at the top of the heap. Next are the elements from the array, which is the next after 32 is 45, then 47. They are the children of 32, and now 32 is the parent which is less than their children. That is the property of mean heap. Then from 45 is having the 2 children like 85 and 66. So 85 and 66 both are greater than their parent. So it is again the property of mean heap. Then 47 is having children 60 and 80. They are again the parents of this childs of this 47. So according to this, we are having this as our heap data structure. And after that, if you want to find out the maximum from this, so I must say I have to continue, and if you want to find out the max from this, so I will give the choice 3, and the max element from this, we can say that 85 is the maximum. So here it is printing the correct answer. From this, the 85 is the maximum. And again, if you want to find out the mean one, so I must say I want to continue, and here the choice should be 4, and the minimum should be get as a 32, because that is the root of the heap. So here we are getting answer as a 32. So it's giving a correct answer, and it is executing as per requirement. So this is what our E-group assignment, which is based on the heap data structure, which is totally working fine. So here we have completed this assignment from the group E, which is based on the heap data structure. So in next video we'll cover the assignments on the next topic, that is the file organization. So up to that, thank you very much.